That's good.
So just, everyone, just to know that we are recording this meeting. If you do not want to be recorded, please let me know as soon as possible. Thank you. Well, good afternoon, everyone, and welcome to this webinar on data science careers. We are fortunate to have, really good people here who are at different points in their careers, who are here to talk about their career. We have an hour to do this, so I'm going to jump into I want to jump into the introduction straight away. But before I do that, let me give Maria a chance to speak. And Maria, could you take it away?
She's muted. There we go.
Maria, we can't hear you at the moment.
She's unmuted, but we can't hear her still.
Today's a strange. Okay, is that better?
Yes.
That's better.
Replug your microphone. That works. Okay, so yeah, welcome to today's event because so this is like a part of a bigger seminar series which we call the IndabaX Roadshow. And I just want to lose a couple of words about that. The IndabaX is a local satellite event of the Deep Learning Indaba that many of you know. The Deep Learning Indaba is kind of a movement that strengthens machine learning in Africa. Many of you might have been at the conferences. We had like wonderful in-person events until Corona hit, and then we decided this year, like the few people from the organizing committee from last year, we decided we want to do something. So we did. We kind of invited lots of people that do machine learning, that have companies, that are experts to share their expertise, to kind of share opportunities. And this one is a bit more special because Kancho was actually also applying to host the IndabaX. And what happens when you apply, so also our group applied, and then the proposals get merged together. So this is like kind of, like also like a very special one. The last thing I want to say, we have a few events left in this month. So the IndabaX Roadshow ends at the end of November. There will be like a big finale. And we have a lot of awards and competitions and prizes up for grabs. So I think it's over, altogether it's probably over 80,000 Rand that we really dish out rather freely for people who, apply and motivate and convince us that they are worth, being awarded for their efforts in machine learning. This is it for me. I will post links to the website and enjoy today.
Well, thank you for that, Maria. You can also send me that information and I can email the group that who registered for this event. We had over 160 participants who registered for this event, but unfortunately, some of them may be experiencing load shedding. In fact, we are experiencing load shedding here at Stellenbosch at the moment, and I'm hoping that the electricity comes back in the next few minutes before, either my battery or my phone, which I'm using as a hotspot, dies. Okay, so I'm going to ask everybody to introduce themselves, the panelists. But before I do that, let me introduce John, because John has got a voice issue at the moment, and John was probably part of the panel. So John Mccomb Berenwa is a data science executive at Corporate and Investment Banking Digital at Standard Bank. And he's also part of the Stellenbosch University Standard Bank Data Lab. He has a MSc from University of Witwatersrand and is a sponsor of the lab, as I mentioned, here at Stellenbosch University. He leads a team of data scientists and technologists building innovative solutions for the bank. He has lost his voice, so he won't be speaking, but what he will be able to see is some of the questions in the chat room. And if people have questions in the Q&A part, I will post the question to him, and he could always type the answer to those questions. Can we, in the meantime, ask each person to introduce themselves? I'm just going to go in no particular order. Jacques, why don't you go first?
Yeah, thanks, Kancho. It's great to be here and participate in this event. So I'm the founder and CEO of Cortex Logic, which is an AI company, which is actually part of the Cortex Group. And we spun out some other AI companies. One is V Teams in partnership with Media24 that's focused on AI-driven kind of a personal wellness companion for teenagers. Quite excited about that, rolling that out to schools nationwide and then globally as well. But for me, it's all part of that massive transformative purpose of how to shape a better future in a smart technology era. You will see this in my book, Democratizing AI to Benefit Everyone. And the subtitle there, Shaping a Better Future in a Smart Technology Era. The audiobook is also available worldwide. And I do share quite a bit of the AI use cases, all sorts of details from a data science career perspective. I think it would be very interesting for people to read that as well. So I'm very much entrepreneur, a smart technology entrepreneur, building these kind of businesses. I'm also involved with the Machine Intelligence Institute of Africa, which is a non-profit organization. And we just recently, last year, actually got accredited by MICT-CETA for data science, machine learning type of courses. We're working with the Student Hub to actually push courses through their platform as well. So there's some activities on that front. We've been doing some collaborative research with our universities in Africa and as well as in Europe about AI diffusion in Africa. I've been personally also supporting Data Science Nigeria, Kenya AI, and a bunch of activities across the African continent. So it's all part of that massive transformative purpose to help shape a better future. My background in history as well, I sold my first AI company to General Electric in 2011, also an AI company. I do document quite a bit of that experience over 2 decades with, well, it's actually from probably 14 years at CSAN Systems. And then obviously 5 years at General Electric as well. But it's all about operationalizing AI across multiple industries worldwide. So it's not just financial services and consumer-facing businesses. In that time, it was very much industrial, manufacturing type of spaces globally, and learned so much in terms of how to apply AI, even with the traditional machine learning toolboxes in the 2000s. And obviously the door opened with deep learning and what we can do with text and other types of data, video, audio, over the past decade, and self-driving cars, all these kind of things. And we're also tapping big time into that as well in terms of what we're doing now. As we built intelligent virtual assistants and all sorts of different things. But there's a lot more to unpack, I'm sure, in questions as well, but that is the starting point.
Oh, thank you for that, Jacques. And if anyone has any questions for any of the panelists, please go ahead and post in the Q&A, and I will read it out to the panelists to answer as we go along. Yeah, Jacques just talked about text data and deep learning, so it seems like a good segue to ask Jade to introduce herself, because my understanding is Jade does work in the intersection of those two spaces. I could be wrong. Jade, tell us about yourself.
Yeah, thank you for having me. Yeah, it's good to see everyone. It's been a while. So yeah, I'm Jade. I am I'm head of data at RetroRabbit. And so RetroRabbit are a software consulting firm, digital products firm. Been in the business for about 15 years. Been working in the data space for around 6 or 7 years now. Largely focusing on like operationalizing machine learning models, and specifically in the realm of NLP. I have a computer science master's from University of Pretoria. And then 2 years ago, I co-founded an initiative called Masakane, which is a grassroots research, open data, open source organization focusing on NLP for African languages. And for this past semester, I have also been lecturing NLP at WITS. This is why I'm very tired.
And it's the end of the week.
Yeah, and the beginning of November. So.
Thank you, Jade. So Marcus, can you introduce yourself to us and tell us where you work and what you do?
Hi. Thanks, Anshu. I work as a data scientist at a company called Runway. We manage a portfolio of online retail websites, mainly in the fashion industry. My Runway Sale, and Fixel. I work obviously on model development and deployment, as well as obviously experiment design across all our platforms for our users. I have a master's in advanced analytics and decision sciences from UCT and undergraduate in finance. Funny enough, Kanchu was actually my supervisor for my master's. My research interests have mainly been in social and spatial econometrics in finance. Yeah, I think that's a nice summary.
Great. So we'll come back to some of that later, because I have a question for you, because you didn't study the traditional, undergraduate in computer science or statistics to get to where you are now, but we'll unpack that a little bit later. So let's start with you, Jacques. I mean, I think you have a traditional background in data science, you one that includes a PhD in computer science. So, can you tell me how this opened up doors for you? In fact, a PhD in computer science kind of opens up multiple doors, right? Not just in AI,
100%.
but in lots of things, and in non-traditional fields as well. But you chose to go into AI. Why did you choose into AI, go to AI, and how had your degrees and your education helped you to get to where you are now?
Gotcha, that's so good. Yeah, no, so it was so interesting. I got a computer when I was at school and got into it and programming and stuff like that. My first year, Stellenbosch University, I had bursaries also from Armscore and Millistan, all these kind of places, big pattern recognition and so forth. And I was actually exposed to machine learning applications as part of my kind of holiday work, so to speak. And then from there on, obviously we've at computer science, machine learning was part of the subject, especially with second, third year honors and so forth. But I've got hooked at that point. And what was interesting, I started my honors also machine learning quite a bit, but then we did the whole spectrum: fuzzy logic, genetic optimization, the whole spectrum. I did my master's, my honors project, master's thesis, as well as my PhD was based on machine learning, AI, parallelizing AI on transputers. My master's, one of the chapters in the master's was about that. My PhD was on recurrent neural networks, training dynamics and complexity of recurrent neural networks. But I covered the whole spectrum, and I just saw the massive applications around this toolbox. Look at the smart tech toolbox. There's so much that you can do. So whilst at university, after my PhD, I was a researcher, lecturer at university, senior lecturer, researcher, straight away. And I actually started collaborating with the business school, with chemical engineering, electronic engineering, and also psychiatry. And one of my books here is Neural Networks and Psychopathology, that I co-authored, co-edited and authored with Professor Dan Stein, who at Department of Psychiatry at Stellenbosch is now one of the top researchers in the country worldwide in OCD and psychiatry, but he's at UCT. And I just caught up with him as well. But anyway, the bottom line is we started applying neural networks even to brain disorders and all sorts of things like OCD and so forth as well. So it was one application area. But even with the business school, financial applications, with chemical engineering, I actually there met some of my co-founders of my first AI company. So actually university opened up the door, and the application route, because we were always interested in I was interested in solving problems using the smart tech stack. And so it was fascinating to see how we can do it. This is like magic. And what was unbelievable actually, when I started applying this in business, when I decided, okay, I'm going to actually take the big leap to go into business and to become an entrepreneur without knowing really anything much about business, but jumped in there, developed. We knew how to develop these systems from scratch. So we're not at that time. We live in a world of open source right now, but at that time we wrote everything from scratch. So all my students, my engineering students, used MATLAB. My computer science students wrote everything from scratch in C++. And I personally wrote so many machine learning, the whole traditional machine learning toolbox written from scratch, all the different fuzzy logic systems, using genetic optimization for fuzzy logic system. And it was a great, almost like a base to work from, because it gives you a good grasp of the underlying dynamics of each of these technologies. And so things opened up from there, and there's no substitute for the experience, and it's actually a wonderful opportunity to learn out there when you dealt with problems and the data, especially say it's data from Angler, from a mine, and they want to do process optimization, or they struggle with throughput or yield or quality. How do you solve the problem? And you come with the tools and technology, look at the data, and then you start building models. And then from there, it grows, and you can do so many wonderful things. And it was amazing to see the problems that can be solved with traditional machine learning. And now the toolbox is just enlarged, big time, with deep learning type of capabilities. And there's a bunch of other things as well. That toolbox is huge. And I think there's also the combination of blockchain technology with AI DAOs, and we are playing around with all that, with cryptocurrency, blockchain. I'm not just linked to one piece of technology. I'm thinking about the whole smart tech toolbox. But it's a wonderful world. There's so much to do, so and solutions to build. So I love to create and to build solutions. But anyway, so I know I expanded quickly, but going back to university, that was kind of the roots, and I can go into more details there if you want as well, to unpack it a bit more.
Oh, thanks, Jacques. I think I do have some pointed questions which will help to unpack some of that later as we go along. Jade, let me ask you a question. So you have a similar background with an MSc in computer science, and that could have led you to work in a number of fields and in a number of companies. Your qualifications are obviously high in demand. Tell us how you end up in data science or ML rather than another part of CS or computer science, and how much of your knowledge from your degree are you using in your work? You know, when you do a master's or you do an undergrad, you don't learn every single method, data science method out there. So how much of your degree are you using now, or do you think you are more set up to, to learn the basic, and now you have to self-learn new methods as you go along, in your work?
Fun question. I like it. The world of AI has changed completely in the past 8 years. And I did my master's and my honors and all of that long before that. And so back in my day, sure, we had neural networks, but kind of black box optimization was the big hype, whether it be genetic algorithms or swarm-based techniques. And so I have to say that, I found myself using very little. And when I did have to, when I did get the opportunity to work in the part of AI that I wanted to, which was NLP, I found myself having to relearn everything. And so the degree didn't really set me up. And I think that's not the degree's fault, because simply it didn't know what was coming. And I even think today, most degrees still need a lot of help, right? I don't think we've only in probably the past 3 years really figured out how to productize ML models. I still don't think we've entirely worked it out. In fact, I'm very cynical about AI in general. It's a long conversation. So if I was looking at kind of why I ended up in this field, it's because it's something I always wanted to do. I intentionally had to seek it out at the time. Machine learning wasn't a big hype. It was a big risk for a company to start to invest a lot of time in it at the time. But I knew when I was, 10 years old that I wanted to build my own robot friend. And, that's why I studied it in the first place. And cool, I'm not building my own robot friend yet, but, working on NLP was as close as I could get. And so I actually started off, I actually hated doing my master's. I didn't enjoy working alone. I ended up, while I was working on my master's, ended up working at Director Rabbit and being a software engineer. I found that very rewarding. And it's very rewarding because you get such a quick turnaround time. You work on something for 3 months and then, millions of people could be using it in 2 weeks. And that's really, really exciting to me. And from that, I got the opportunity to, as soon as I got a project that had some vague relation to AI, that, the founders of that company were.
Jay, did you finish answering the question? I presume you did.
Okay, great. So continue.
Yeah, I mostly finished. I wanted to end up with a rant, a small rant.
Okay. I look forward to hearing the recording.
Yeah. Oh no, I didn't say that. No, I'm waiting till we had everyone here to make sure it was recorded, because it stopped recording as you dropped off. And so yeah, the small rant is around. I think we're focusing. We've been focusing a lot on data science. And that's all good and well, but actually we've operationalized a lot of data science, as in we've productized it. We can upload data and get it done and download results. I think the really hard bit is the data itself. I think we're not paying enough attention to it. I don't think companies have invested properly into it. I think this has hindered kind of development generally. And so what I'll kind of want to inform, since this is a career panel, just like inform our attendees, is that if you want to skill up on something, it's data engineering, and that will make sure that you have space to move in your wherever organization you end up, because you might, instead of being blocked by the need for a large amount of software engineering, you can then take that up and make it happen and bring yourself the data. That's the end of my rant for now.
Cool. Thank you for that. So one thing that Jade mentioned was she didn't enjoy her master's. So Marcus, you can't say that because I'm here in the room, but you have the least traditional kind of entrance into data science out of all the panelists here. And so you went from, a finance degree and you pivoted into data science. And machine learning, etc. Can you tell us a bit about yourself, how you did that also, but how you thought about going from finance into this area that at that point you hadn't been taught much in that area, right? At the time you started thinking about becoming a data scientist. So how did you find out that you'd actually like it when you went into it from finance?
Yeah,
so
well,
while you're talking, I'm going to try move away and get my computer set up, but I can hear you because I'm just behind this computer.
Great, Kanchu, great. So, I mean, Kanchu said I was kind of a non-traditional background, but I mean, if you look at finance and if you look at financial markets, I mean, they've been run using AI algorithms for years. And for me, it came as kind of an epiphany in many ways. I think I finished my time on the SRC after 2 years as its treasurer and on UCT Finance Committee. And I was kind of at a precipice in my life, and I did a few internships at various different companies at the time. And I ended up sitting down with a family member of mine, and they were like, well, what do you want to do? And I kind of decided in that moment it was going to be data science. And so rather than kind of letting go of stats courses, I just carried on. And so I ended up, while doing my finance degree, finishing 3rd year stats, then finishing 4th year stats, and then going on to do a master's degree in the stats department at UCT. Jade, I thought what you said was quite interesting. And hopefully we can get a bit of a discussion going around this, where you said there's a huge gap at the moment in data engineering, right? And I think you're right. And I think this is a very interesting discussion for us to have within this particular forum, which is what are the kinds of skills which we see this career needing and needing to develop in order to move forward. I think I agree with you. I think data engineering is probably one of those skills where there's a huge room to include those in course curriculum. But I think at the same time, if I look at a lot of the skills which I rely on, I mean, I've been doing a lot of data warehousing recently, so data engineering is definitely one of those. But I think at the same time, there's a huge amount of value in tools like, operations research and experiment design. And very often, I think companies go down the wrong rabbit hole thinking they need to warehouse all their data before they can start adding value, when often the small data sets, which are really well maintained, used across organizations, are the ones where you can really start adding value. And so, funny enough, about a year and a half ago, I wrote a blog post on LinkedIn and on Kaggle about this, and I actually reviewed, I think, the top 15 online nano degrees in data science. And what I found consistent across all of them is all of them obviously went through, k-means clustering, they went through introduction of random forest models, but very few spoke about, I guess, data engineering. But more importantly, I think many of the topics in how exactly do we go about productionizing the models, but more so actually, how exactly do we go about socializing these models? How do we go about developing skills in data science or machine learning product management, right? In order to develop and think through the kinds of models we need to develop in order to add value to our business. And I think, I've competed through the years in a number of Zindi competitions, Kaggle competitions, and thankfully done quite well in a number of them. But I think quite often, the modeling question is not the complicated one now. In fact, you can get really, really far using many off-the-shelf AutoML tools. Right. And so I think the skills which as a profession we must really look to develop is the skills obviously in kind of model explainability and stuff like that, but in also how exactly do we go about socializing and designing and looking at business systems and systems of people within our organizations that we can develop the models which add value. Because it's very easy to impute any random column, to predict any random function, right? But not all those functions, right? Just serving a prediction on a dashboard of future sales forecasts is not going to drive the kinds of business decisions or drive what's needed in order to identify the change which needs to take place within an organization. And I think that's partly where skills and experiment design come in, but it's also where we have a huge amount of room to push the needle as we develop these more specialized programs like at UCT, like at Stellenbosch, like in many other universities around the world, around the country, in developing more of these, I guess, like business and information systems type skills, which I think have been missing out of traditional computer science type courses.
Yeah, Kanchu, I can add quickly to that.
Sure.
I fully agree with both Marcus and Jade as well there. The way I'm looking at this, for me, it's not just, we live in an API economy, plug and play. There's Lego blocks all over the place. You get proprietary, commercial, all the different things, all the different types of components that you can start using and so forth. And a lot of the stuff is being automated, like AutoML and so forth as well. And we're using APIs. It's like horses for courses, and it's swapping things out. It's Lego blocks. So the skills that you need is to understand those Lego blocks, what they do. So it's more on an abstraction level, input-output level as well. But if you think about digital transformation, AI-driven digital transformation, there's the 5 pillars in terms of data, technology. You've got people, processes, intent. The intent is around strategy. What are you trying to achieve here? What does that business use case look like? I mean, that's very important from a data science perspective. So very important to look at the 5 pillars when you implement things. So I'm looking a lot more holistically at this, and I'm thinking much more, you need to think like a solutions architect. Think about, I think that kind of skills, and let's kind of latch onto what Marcus and Jade was also saying. So those are things that's valuable. The fact that I do have deep knowledge on all the pieces, effectively, deep knowledge on the deep learning pieces, but also all the traditional machine learning. And a lot of those pieces are still relevant. We've got state of the art. This is like a separate thing on outside Cortex. We've got, we even on trading, on FX trading, and we're using physics, math, and some random forest and also other types of techniques. We don't use deep learning there because it's not needed there. Horses for courses. If you think about NLP that Jade is working on, there's no question about, so if you look at Google Translate or natural language processing, do you have to go to deep learning type techniques because that's state of the art. There's no question about it, and it's growing, and it will grow into the semantics, and there's lots of interesting stuff on that front. So the point here is just about be sensible about having a good understanding of the smart tech toolbox, and be smart in terms of how you apply it. And it's almost like the interfaces as well. Understand exactly, this is what it does, and where it could work, and so forth, and understand the weaknesses and strengths of the various techniques. Yeah, anyway, just wanted to add that in.
But Chuck, I think it's one level different from that. I think that's what Jade and Marcus are saying. So one is the methods and all that stuff, but the other is the data engineering, which is very often not taught at universities and in degree programs. And you know, what people do is they have these toolboxes, and then everything is seen as a nail because they've got a hammer. What is that saying? Something like that, right?
Well, I would add to that. So I just want to say data engineering is for me part of, when I talk about the 5 pillars, data is a very important part of it, data engineering. And even there, you've got the API economy functioning on a deep level, on multiple levels around that. So, but that's clearly a gap. So I absolutely agree. It is almost like not enough focus on helping and sorting that base layer out. And we've grown that layer. So with the smart tech toolbox, it's powerful enough to work with all sorts of different types of data, the text, the IoT, it doesn't matter, the whole spectrum of data. And you need to be smart how you deal with that in the cloud, on the edge, in the fog, all the different spaces where you can operate with data as well. So I fully agree.
So I mean, one thing that gives me heart listening to this panel is, at University of Stellenbosch, 2 years ago, I think we started offering a Bachelor of Engineering in Data Engineering. I think it was one of the only few programs in data engineering. Of course, in that program, you learn data science in the more traditional sense as well. And last year, we started a program, Bachelor of Data Science, where you do the normal data science curriculum as well as an additional domain area, and one would do data engineering in that too. Let me move the conversation to slightly different, and I think it answers some of the Q&A that's being posted here. So, Jacques, let me start with you. So you are a CEO and you manage people, right? What is your experience on which majors really matter and the type of skills? So we talked about data engineering, but there are other types of skills that one needs. Are you mostly looking for people in a particular major, or would you take, say, a chemist who has skills, who has the skills and the ability to learn data science? And if the answer is the latter, how would you provide them with the skills to pivot into data science? So let's say they're a freshly chemistry major. I think Intando Lele is asking that question as well. Yeah. How can one move from chemistry to data science career? And is this appealing to you as a CEO to hire such a person?
Great, you're talking to me now. Yeah.
Okay.
Yeah. No, I just wanted to, absolutely, Kanshu. As a matter of fact, our current team consists of a spectrum of people with masters in stats, PhD, physicists. I've got the whole spectrum. So it's people that can work with data, that demonstrated skills. They can think about problems, and they've got also a good grasp and knowledge of the toolbox. Well, effectively Python, R, those kind of tools, and also open source, what's available in terms of APIs and so forth, and to engineer these kind of solutions. But currently, for me, it's a spectrum of people. So we're using a lot of software, pure software engineers to help us, because we're building mobile apps and we're building cloud-based systems. So data engineering is very important, part of it. As a matter of fact, some of our data science just focus on data engineering and making sure that the whole data science infrastructure is in place for scale as we work. And especially in our case, we're creating our own data. So we're building these scalable data science infrastructures so that we can generate the backend intelligence for the nudging and the interaction with the users on the front end via the apps as well. So, and we're actually using machine learning AI on multiple fronts, but on the human-computer interface side, when you've got intelligent virtual assistants and, sorry, I just want to switch this off. Intelligent virtual assistants, and you obviously need to use, there's some AI on that front as well, but then there's quite a bit of data science, traditional data science, the things that we've done for our corporate enterprise customers for many years at C-Sense and also at Cortex with the AppSas and the Clixes and the Beers and all these kind of companies where you actually deliver end-to-end AI-driven solutions. And when you're in, the modeling side is a small part of it. There's so many other pieces. The data engineering is a huge part of it. How to operationalize it. I can see that Jade and Marcus speak of experience, because this is just, when you're in the real world, there's a lot of other pieces that you need to put in place to make solutions work, and to make sure that this is delivering this, the whole solution is actually working in real time. One of the things that we did, just as an example, is kind of at the forefront. If you think about dynamic home loans pricing, how do you individualize pricing for home loans individually, and how do you make it real time? Thinking about real time market dynamics, think about individual circumstances that might change in that part of a certain life cycle. There's a lot of time series, but a lot of dynamics in there as well. How do you construct the problem, and what kind of tools do you use to actually solve the problem? So there's many pieces and many layers. Getting the right data, putting it together, massaging the data so that the right techniques can be applied. You want to almost help the modeling techniques to do these kind of things as well. So, and then you need to think about, what do you do with the outputs? How do you integrate that into a system, in a real world system that you can trust, that is actually dependable as well? So there's lots of layers there. And then you need to think about, does this whole system replace people's work? How does it automate certain people's work? How do we change the job, the task within jobs as a result of implementing this system that automates this piece as well? So there's a lot of things that you need to think about as well. So finally, to answer your question, so we've got a spectrum of people that can help implement those type of solutions. And even though we've moved away from AI enterprise solutions to taking full control over our AI-driven platform businesses and mobile apps and solutions that we drive, especially now in health, wellness, and financial wellness, there's a huge focus in that area. Health is a hugely important area. Those are the kind of people. So it's it's like software engineers talking to data engineers, talking to AI engineers, data scientists, the whole spectrum. And then there's product management. So there's a lot of interaction across multiple roles where people work together in an agile way to actually deliver these solutions. And you've got to be quick and fast with these kind of things. You can't be slow. So you've got to think about time of delivery as well. Yeah, anyway. So hopefully that helps.
So one of the things that you mentioned is the wide range of people that are working on these things, right? So Jade and Marcus, I'm going to pose this to you. How about from your experience? Do you work with the wide range of, let's say, majors from universities? And how does one enter data science if one isn't in a traditional data science technical degree? How can one upskill themselves and get themselves market ready so that they could be employable in the data science world while having a non-traditional, let's say, degree.
Cool. So from my perspective, I say the easiest way is to get experience in software engineering, whatever that might be. So if you're not coming from chemistry, if you're coming from chemistry or another background, you probably haven't been exposed to software engineering principles. And I think it's one of the easiest ways to get into data science. And I think often companies might be, these days, I think are becoming, they've hired a lot of people from these backgrounds, realized they didn't have the software engineering background, and then found that they didn't have much to add at those stages of the project. And so to be really useful throughout the project, having some software engineering experience, and this can be go work on open source projects, this could be doing courses in your own time just to understand the software engineering lifecycle. Even a year of software engineering kind of practice and experience is a really good way to enter data science, because as someone with a BSc major, you've got the core component, which is you're a scientist. You understand the scientific procedure. You understand how to do science, to run an experiment, and that's super important. And the only thing you need to add to that is kind of this computational edge to give you kind of finesse in that field. That's my perspective, but also I come from a software engineering background. So I have a bias in that way. I'm looking forward to Marcus because he comes, I think, from the other side.
Marcus.
I mean, a lot of the time when you start a data science project, I think the most important thing you need to think about is can you make a business out of this, right? Can you actually drive value? Like, can you charge users money for access to this API? And I think it's in fact, data science is one of the easiest ways to spend money. It's the easiest way to spend money, right? Like you can store terabytes worth of, so easy. I mean, like if you look at like Databricks, even their smallest instance, which you can serve a model on, is like a AWS X large or something like that. So, just to begin with, your model's going to be like 16 grand a month or something like that in serving, right? Easy way to spend money. But you need to think, I think, very importantly about, is this something which, as a product we can monetize, is something which we can serve and add value to? And I think it's really important to obviously be science driven. And I think obviously being able to program the problem is really, really important as well. But I think being able to understand, is this something which we can add value for? Can we charge users for? And what kind of value can we expect, right? Like, looking at online retail, there's a huge amount of money to be invested, and there's a whole bunch of off-the-shelf solutions in personalization, right? Being able to drive product recommendations, retarget customers. But what is the actual gain on that, right? Over something like just recommending the most valuable product. Now, I've actually done a randomized control trial on this, funny enough. And what's crazy, I mean, that was something which was incredibly cheap to do. But the difference between a personalized recommendation and just some random recommendation is like 12x, right? In terms of like your click-through rates. But being able to look at, what is the differential cash flows which we can expect from this is an important standing point, and something where I think being able to bring a range of different skills and views is crucial to building this data science journey.
Cool. Thank you. Thank you for that. So I guess there was a question in the Q&A just now. I forgot what it was. No, sorry, I need to find it because it's also going into the answered part. But I guess whatever it is, which postgrad would you recommend, or online courses that could be useful, right? So this my next question kind of relates to that. So, and this is a question open to the panel. So in the US, it seems one can get a job by having an analytical degree and then showcasing their talent by participating in like Kaggle competition, etc., right? Kaggle and Zindi, etc. Is this a genuine way to enter this career by, let's say, having a chemistry degree, learning data science on your own, doing these Kaggle competitions and Zindi competitions and doing well in them? Or is that not the way to do it? Or is it more that the Kaggles and the Zindi competitions, does it just supplement and complement rather, your traditional data science degrees or some other method of getting into the data science world? Yeah, so that's open to everyone.
Yeah, I would say, what I like about Kaggle and Zindi and so forth, if you don't have the luxury of being exposed to problems and data and so forth, that is an unbelievable opportunity to hone your skills and because it's also super well defined. The real world problems is typically a lot more elaborate because it's not just building the model, which is just one piece of the whole thing, but it still gives you great exposure to just working with data to try and solve a problem. I've been fortunate with Cease and Desist, my first AI business, and obviously from there onwards, to be exposed to so many companies across the globe where you got a very specific real world problem. You get data, and we built this troubleshooter tool, CSense Systems, it's a CSense troubleshooter tool that allows us to very quickly, within 30 minutes, you build very quickly models. And we actually, what we did was to build machine learning models along with rule induction models, along with, you build these models in parallel, and it automates the things, almost like with AutoML type of systems that we've built those days. But very quickly you build stuff. But then what we did was, that was just the first step. Then we started interrogating the model, doing causal analysis, sensitivity analysis, extracting knowledge from the models, from the machine learning models. And obviously with rule induction, you do have those rules extracted straight away. But that just gives you a bit more insight into what's going on in the process. So typically the models is models of processes or piece of equipment, say if it's an industrial space. And it puts you in a position where you can start motivating business cases and say, for say advanced process control solution, where you say, if we implement a solution, a model that simulates this process, and we can optimize these particular manipulated variables, we can optimize this whole process, and then we can motivate why we can have a 1%, 2%, 3% increase in throughput, yield, quality as well. So anyway, the bottom line is there was exposure to data and real world problems and solving it. So I think Kaggle, Zindi, all those kind of things is very good to at least start to expose. It's almost like democratizing that part of the modeling at least. And I think it's valuable. My son is first year university now, and he's Stellenbosch.
Yes.
Yeah, I was Stellenbosch. He's going to be Stellenbosch as well. And he's doing, what's interesting, he's also following pretty much my direction, but he's doing a combination. There's a new electronic engineering degree where you do data engineering with data. So it's a combination of computer science and electronic engineering. And that's a great basis. So he's already first year doing data science, statistics, all of those kind of things, along with the other things as well. So I think it's a wonderful kind of degree because it gives them a lot of the building blocks. But the reason I mentioned that as well, even before that, when I talked about AI and machine learning, he started doing courses and Coursera and this course and Udemy, and there's so many. Google has got wonderful courses as well that just free. And obviously you work with their environment, their libraries and so forth, TensorFlow and so forth. But you learn quickly how to do this, and they've got wonderful high quality material there. As a matter of fact, we are using some of that material also in the Machine Intelligence Institute of Africa courses that we package for the Student Hub and so forth as well. But the bottom line is, I think there's a lot of things that can supplement university training as well. So I would encourage, I have a multi-pronged strategy around this. Try and learn, just use all the avenues to learn as much as you can. And not just the technical, the academic or the theoretical stuff, but the practical, especially AI, machine learning data science is a practical science. So you want to be exposed to real world problems. So I would I would cover the base and try to just strengthen my skills in those areas and really understand how to use these tools and the APIs.
Cool. So, you're talking about, learn, self-learning, etc. And somebody just asked that in their degree, they largely learn R, but they hear that Python is more useful. And should they go learn Python? And Jade gave a great answer. It's in the Q&A part. Industries often requires flexibility on languages. After learning one, you realize the others are much easier. Getting some familiarity on multiple languages would be useful, in my opinion. Exactly. And I think what happens is, you learn R. Once you learn one computer programming language, the next one becomes really easy. There are so many free resources out there that I would learn all the big ones just, for the CV and for marketability's sake. But in reality, you can go from one to the other quite easily, right? And I would try try to learn the Python if you are doing art. So, for example, you may not have got this. I forgot this person, Chad. I don't know if you're at Stellenbosch University. I think you are. We offered a free course in Python earlier this year. So that is an opportunity for you to take part in such courses and learn Python or learn other skills that are offered, not just at Stellenbosch University, but at other universities and other platforms like Coursera, edX, etc. Right?
I agree.
I would add to that.
Sorry, go on, Marcus.
I would add. So, I mean, I absolutely love Kaggle. I mean, I've completed a number of competitions, and I also have a number of notebooks, I think like 50 or something like that, which I've put out to people. And I think if you're going to choose a language which is like really, really popular, where like everyone, which has like a really exciting open source community, because particularly if you're a student, like don't think about like what's demanded in the work world, because I think these days, largely the open source community will set what is adopted by industry in 5 years' time, right? Industry is downstream, if anything. But the other thing is that if people are producing a huge amount of open source tools, a huge amount of tutorials, a huge amount of content around how to operationalize these technologies, learn something which is really, really popular, because you'll learn a lot from other people who are doing exciting things in that particular programming language.
I just want to concur what Marcus is saying as well. So we're using Python heavily, but JavaScript, we use React Native. There's this whole combination of things, obviously for the mobile apps, but from a data science perspective, my son is doing R as well, and he knows Python quite well because he's even at school he learned Python. But I agree with Marcus. I think advice also look at what's because you will get a lot more examples and resources and things around those kind of popular languages as well. So, yeah.
So Jade, you had your hand up. You can just unmute yourself and speak.
Oh, no, there was a lot going on. So I kept on muting and then someone would talk and
Jade is doing a very good job of answering questions here, because I see them open and then they just disappear to answer.
I know.
Sorry. I didn't realize it became done after I answered it. It was saying, surely we should all answer.
Jade, that's how we compliment one another. I'm not going to answer like that. I'm going to answer verbally, so go for it.
Oh, cool. Yeah. So the thing I wanted to add, and I think what's really overwhelming if you're a student, is there's too much almost.
Yeah.
It's really about like, what can you focus on? And so if I am looking for one thing, if I'm, hiring a junior data scientist, it's not Kaggle, because I think Kaggle leaves out too many parts of the process. And sure, like spreading out your bases can feel good, but it's also very hard to do. If I had to suggest one thing you should do is come up with an idea for a data science. So have a data science question, maybe something about the recent elections where you've got a lot of data, maybe something that interests you.
COVID.
About some other thing. COVID, there's data sets available if you look online. Ask this question and then try answer it using data science, and then have that demoable or shareable so that you can share that as part of your CV. So this is the thing I would look for if I had to pick on one thing, particularly if you're not coming from a standard background. This is something that will demonstrate that you understand what's an important question to ask. You can try reason about it. You've taken initiative to do it. You have the skills to put it together. And so that's, and you can maybe even scrape a data set, which is also very important depending on the type of question you're answering. So if I had to say one thing, do that, and sort of regardless of language, do that. If you want to do that plus times 2, turn it into a little app. This is becoming really easy these days. So like make it something that someone can play with, and that will require you to learn something like a little bit of JavaScript. It will require you to learn like maybe a little bit of HTML, and that's fine. These are all really good skills, and you'll have that going throughout your careers to point to. So if you're doing projects at university, finding a way to put those online and show them off is actually a really good way. At university, the only thing at me hiring a graduate, the only thing I can do is look at what you've done at university, and so making that easy for me to go look at is very helpful.
Cool. Thank you for that. And also John Mccomb Berenwa adds that in a few years, Scala, Jade, Julia might be famous languages. So as long as you understand the flow, syntax can be learned later. And I found that with with programming always. So then there is a question from Kaelo. Questions for Rajaratnam. You have asked good questions regarding individuals looking to pivot to ML and AI from other careers. However, what roles do institutions play here? For someone who does not have maths or CS undergrad, however, has informatics or others, should one go back to zero with an undergrad? And I think the answer is no there, right? So when I'm taking the institution here as educational or higher institution, and I think the answer is no there, because there are degrees that allows you to pivot from zero data science knowledge, but from a technical background into data science careers. There's also lots of resources out there, and some of the things that people said here earlier. I mean, we used the example of a chemist wanting to go into this career. So chemist, I think, is far more removed from data science than somebody with informatics. So whatever the chemist needs to do to get into a data science career, the informatics person can do the same or even less and get into this career. So, like Jade said, learn software engineering, right? Is that, I think, what you said, Jade? I don't want to misquote you. So I think there are lots of, I think we've answered many of those questions. You just have to think about what is possible given your situation, because, not everyone can go back to full-time studies. But I think there are lots of resources and possibilities out there for somebody to take this and run with a data science career, right? Marcus did, what do you call it? Add some more comments there in terms of Python is not the only way to go. And what is nice is that it's a language that is used by backend devs with like Django, so you can learn best practices from those specialists and easily integrate with the code base, right? Let me just go into a couple of other questions that I'm seeing on the Q&A. So Ashley, I have to ask you a question. We were in touch yesterday. I'm a bioinformatics student and use R for statistical analysis. I'm learning Python and writing a proposal for machine learning application in infectious diseases using omics data like RNA sequence and protein data. What's the best way for me to transition to a data science focused career after my PhD in bioinformatics? What are the skills I need to enter the data science field? I think some of it has been answered, some perhaps not, but I'm going to open it to the panelists to see if they want to add anything more to that. Okay, the panelists are quite quiet. Marcus?
Yeah, I was going to say, I mean, I think, particularly if you want to transition in your career, I think you're at a position where you do need to expose yourself to a lot. It might be that you really have a deep understanding of this particular model or this particular machine learning application. But I think particularly if you want to stand out, you really have to expose yourself to a lot. And I think that's not just to look at on an application, but I think also to fill in as many gaps which you might have as possible. So particularly if you're coming from, say, a chemistry background or biochemistry, look at where your weaknesses are. Maybe that's in like software engineering, maybe that's in infrastructure, learning something like Docker or SQL in order to fill in those gaps and fill in those gaps. And then I think find opportunities to demonstrate your knowledge as well through open source, through projects like Kaggle and Zindi. And I think Jade, I think, mentioned a lot of things I also don't like about Kaggle and Zindi, but what I do like about it is I think it's a great way to see that the candidate is like really passionate, excited about data science. And I think it's such like an inverted commas intellectually honest place, right? Like, so I have like an open source library called TF Tabular, where I've re-implemented a lot of state-of-the-art PyTorch models for tabular deep learning in TensorFlow. And what's amazing, I think, about a Kaggle and Zindi as platforms is it's like really easy to be like, oh, my method like does really well. But you learn after like the new XGBoost or CatBoost launches, that like these methods really work out in the wild with these platforms. And I think particularly for students as well, there are a lot of like really core skills from a science standpoint in like doing cross-validation properly, right? And thinking about like what is the best way to like structure my cross-validation schema in order to arrive at robust results. And those are like skills which I think aren't necessarily taught in depth, even in like a stats program or a machine learning program at university, but it's something out in the wild. If you look at winners posts by Kaggle Grandmasters, you see them spending a huge amount of time thinking about how do I cross-validate my data? How do I blend results across multiple models and ensemble these models? I mean, like these are people that obviously do incredibly well and are experts in their field of just predictive modeling, and there's always going to be a place for them. And they are people in many ways, I think these days, that are like leading the charge in actual many practical specialist machine learning type problems, because they have all these conversations with each other. Like Try Time Data Science is a great podcast on this, And almost all their discussions are like, how do we go about like optimally blending and cross-validating models? But that's not something which I think industry thinks about enough, and I don't think it's something academia does. So it's a wonderful, honest place to like really express your patterns and learn from people as well.
Cool. Thank you for that. So we kind of running out of time. So Marcus, could you please type the name of the podcast in the chat room? Lise Prinsloo says, thank you, Jade. At the moment, my goal is to pass my degree. So your advice to start a mini project with the question sounds really good. And I'm going to ask the last question to Jacques before I get some last comments from all three of you. Martin asks, what are the top 3 considerations when starting a successful AI company, Jacques? And you've done that. So can you tell us the top 3 considerations?
Well, I can tell you it depends on what is the type of AI company that you want to build. Because you can build AI enterprise solutions, then that would be, well, there will probably be commonality between that. And we've transitioned from just pure AI enterprise solutions to where you actually say, I'm solving an industry problem or a big problem. So you've got to ask the right questions. You've got to say, is the problem big enough? And for me, it needs to be anchored by a massive transformative purpose. And in my case, it's shaping a better future in a smart technology era. And say, for instance, we want to say, when you use smart tech for social good, what is the kind of industries that I want to focus on? And what is the kind of problems that I want to solve? So I think it's important to have those kind of questions sorted out. And then once you've got that sorted out, you can think about what is the kind of team that you need to actually deliver on this. And you need a spectrum of people, not just the tech people. You need to have domain experts. You need to have people that truly understand the problem. You've got to also think about, if you think about the business model as well, there's so many things now with data you can monetize in so many different ways. You can just get traction and then start monetizing as a result of the traction that you've got, for instance. Say it's consumer-facing businesses. So I think it's very specific to the kind of problems that you want to solve, the kind of business you want to build. I think I would like to do this because we want to be as impactful as we can. You can't do everything, so you have to focus. So I want to think about scale. So how do I build truly scalable solutions that not only scale technically, but can scale commercially extremely well. So you got to think through those kind of things and put the people is critical to have the right team to help you execute on that. So hopefully that helps.
Well, thank you. Thanks a lot. So we have run out of time. So I'm going to ask each of you to say, some final words quite quickly for people who want to get into data science. And of course, the people who are doing traditional degrees, I think there's less to say to them, because, whether they're doing it as a master's or undergrad, they've already bought into that. But I guess it's the other people who might already be working or who are doing non-traditional degrees, let's say like chemistry. And I think we have, discussed much of that. But any last words, Jacques, Jade, Marcus?
I think just love what you do. Make sure that life is short. So choose wisely in terms of the things that you want to spend time on. And I'm passionate about using smart tech for beneficial outcomes. So I would just say that, and if you want to be really good at what you want to hone your skills, so do whatever you can to hone your skills in the areas that you're passionate about, and things will work out for you.
Great. Thank you, Jade.
It's sort of exam times, and I want to give a counter argument saying it's okay if you're feeling burnt out and tired, and if you're feeling overwhelmed. This probably feels like a lot right now. It isn't. Finish your exams, get that done, and then pick one project and do that, and just do it nicely. And it's very hard to do because there's just so much distraction in the world trying to pull you into multiple directions. But yeah, those are my final words.
Cool, thank you, Marcus. Your final words, and then I also want to ask you to write the name of the podcast into the chat room.
Cool. I think I already have, but I'll check whether or not I accidentally send that directly to you or not.
Okay.
So I think, if you're choosing a career in data science, I think you're very passionate about data, you're very passionate about problem solving, and you're probably incredibly smart, right? If you were to like look at your high school class or something like that, you're probably very, very gifted. But I think be prepared to fail a lot, be prepared to fall short on tasks, and be prepared to learn from them a lot. And I think a career in data science really requires that. You're required to be a master of everything, right? It's not it's a jack of all trades career. Understanding the business, understanding the data, understanding science, modeling, statistics, explainability, working with people, and you're going to fall short on all of them at some point. And be prepared to learn some really valuable and exciting lessons about that. And don't let it discourage or dim the excitement you have and passion which you share with people, because I think that's really, really infectious. And I think whoever you work with in industries and towards the end of your education even, I think it's really important that you share the kind of excitement you have about data science with them. And I think being in a forum like this is fantastic because, looking at the panelists, looking at people in the chat, we've found a space where we can share that passion with people and hopefully bring that out into the rest of the world.
Cool, thank you. Kyle mentioned something in the Q&A. For anyone who's not coming from a traditional CS background and wants to get into ML, check out Daniel Burke on YouTube. His journey is amazing, self-taught ML professional who has also delivered lectures at Stanford on model development. Pardon? To someone? Okay. So then Tabisa also asked, I major in mathematics and operations research. Would it be advisable to do a postgrad in OR or in data engineering? Tabisa, it depends on what you want to go into next. They focus on slightly different things. So think about what your next career would be, or what your next job would be, and I would go based on that rather than thinking about which is a better degree. Go with what you love and what you want to do. I don't know. Do the panelists agree with that? It's kind of a generic
Absolutely.
answer, but yeah, cool. So just some last words from me. Yeah, so it would be bad if I don't take this opportunity to let the people out there know about the Bachelor of Engineering in Data Engineering that we offer here at Stellenbosch University. There is the Bachelor of Data Science that we offer here in Stellenbosch University. It's the first data science named degree in the country, perhaps even in the world. We have a BSc Honors in Computer Science, and we of course got the more traditional degrees like, we have a BSc Honors in Computer Science with focal area in data science. We have the Masters and a postgraduate diploma in industrial engineering, focusing on data science. And we of course have the more traditional degrees like statistics, computer science, etc. Next year, the School for Data Science and Computational Thinking will offer, it's not a degree program, it's almost a short course program that is self-contained, that has a lot of these aspects that we are talking about, from data engineering, from coding to data engineering to data science, including things like project management and design thinking and how to interpret the data, etc. Much more self-contained, but it's not a degree program. It's to get those people who have limited time, who already have a degree, to pivot into this space. Let me take this opportunity to thank all the panelists who have been here. John, despite his sickness, has been throughout here and has answered questions on the Q&A. Thank you, Marcus, Jade, and Jacques. And thank you, Maria and Christopher, for this opportunity for the School for Data Science and Computational Thinking here at Stellenbosch University to take part in this IndabaX. I look forward to the other, IndabaX events and hope to repeat these kind of things every year so that the community can benefit from all our knowledge and our experience. Thanks a lot, everyone. Have a great weekend.